Hello and welcome to this Unity tutorial video where I've just landed. There we go. Where especially for King Camille, who commented in a previous video, wanted to know more about using a seed to generate a terrain such as this. So what I'm going to do in this video, there's about three things. Let me try and remember now. In the previous video, which was kind of not a tutorial but a coding, like a speed coding challenge, I created these trees. They don't look like trees yet, so perhaps we could make those look more like trees. And King Camille, you asked about the extra code that I put into my project, which I didn't really explain, so I could do that. And all that is making sure that let's see if I can show you, for each of the different tiles that I've got in my scene. So here I've actually got not just one terrain but two squares, and they each generate their terrain separately but using the same what's it called? Simple voxel farm script, as we looked at in previous videos. But if you say wanted to randomize seeds and each script or each voxel farm was doing that separately, then the terrain won't match up at all. And so you've got to have a way to organize and coordinate your different like terrain tiles according to one seed. So we'll do that, and that will involve having game objects talk to one another. So let's set up this project. So I've made a new folder in my project, and I've made a new scene. I've called it Camille Seed Scene. So what I'm going to do is delete what I've got so far. Oh, I'm going to try and delete it. There we go. I'm going to delete what I've got so far, so that all we've got in the scene is, and I'll also delete the script I made. There we go. So all we've got in the scene is a player that can move around, first-person controller, the sun, and a voxel farm, which is just where is it? It's just an empty game object to which I've got attached the seeding farm script. Okay, so this seeding farm script is derived from the script I made in previous videos, but simplified. And I'm going to simplify it even more now. So I'm going to take away anything to do with seed. So let's take away this. And we want to take away seed from here. So I'll do everything from scratch. There we go. Okay, so it's a short script. It's less than 100 lines, and all this does is create a grid in generate terrain, a grid of 100 by 100 voxels. I've just got a nested loop, and then using Perlin noise we decide the Y position of each block, so 100 times 100, and then we create a new block, and we go and grab a prefab. Actually, we grab either a grass block, there we go, or we grab a soil block, depending on the height that we've decided with the Perlin noise for each block. Okay, I've just reminded myself, you might have seen that actually still in the preview thumbnail down here, these blocks are really, really tall. And another comment, I apologise, I can't remember who asked, but we created this Diggly script in a previous Minecraft tutorial, and that allowed us to create blocks in-game and also to dig. And of course, we've just got a thin layer of voxels, that build a terrain. And of course, if we dig down, then we've got nothing underneath. So the question is asked, well, how do we do multiple layers? And really, the method that we're using, where we're just creating blocks, is going to be far too slow to create a massive Minecraft world with lots of layers. But we could think of, I was going to say clever, they're not really clever, we could use stupid little hacks to inventively kind of get around this problem. So what I've done is just, I've only done one thing so far, but you could make each block like 10 high in terms of its scale for its Y component. And then when you dig down, it will give the illusion that you've got this really thick terrain. So that's one way. I think I may have broken my script, so I'd like to go and try that out. Things are not the right colour here. What am I missing? Not sure. Anyway, let's go back to the folder. So we were in seeding. Let's just try and run it. See what happens. Should just look like an ordinary terrain with tree. Oh. Okay. Goodbye. Right. We've got to get onto the terrain. Voxel farm. I'll just put you at 0. There we go. Ah, brilliant. Okay. So very, very basically, we're generating a terrain and trees, or the beginnings of trees. Now let's go and show you this thing about digging around. So now if I dig, so if I press the right mouse button, there we go. I believe all it's really doing is moving the block, which remember is a really tall stalk, down. And so it gives the illusion that you can dig. And it's, you know, you're going to run into problems when you're at the side of a wall like this and you try and dig, and instead of a hole being produced, you'll just move the whole stack down, which I'll try and show you in a minute. But we can also dig. There we go. The problem being here that it might create a massive stalk, because we're not just creating a block, we're instantiating or loading in a prefab. But I don't know, it's a start. That's not bad. There we go. I was kind of like, so if I face a wall like this, it doesn't seem to do anything, but actually it's made it shorter. If I keep pressing, it'll go down and down and down. Okay. So that's for whoever it was, I apologise, who commented in or asked in the comments, how might we add layers? That's if you're sticking to very basic game object cubes, you're not really optimizing anything like this, but you just want, want to play around, then that's one way you could have layers in a fairly efficient way. It wouldn't be very efficient to say create this terrain, then clone it, and then stack loads of them up. But you can achieve a very similar thing by having an elongated voxel. So just to show you the consequences of that, if we return these Y components of the scale to 1 and play this again, the amplitude and frequency of our Perlin noise terrain will stretch the voxels too far from one another, and you'll have these horrible gaps inside, which you may have found if you've tried out my code and changed the amplitude and frequency. So another benefit of having longer voxels is that you hide these gaps and you create a continuous, seamless terrain, and you can have them as large as you like. So let's go crazy. 100, 100. Brilliant. Right. So one thing I said was I wanted to fix those trees. The main thing is to coordinate a seed for if we have different voxel farms. So I'm going to get I'm going to make another voxel farm now, and we'll call this one Camille farm, in honor of King Camille, and this needs to be at least 100 away. We'll put you 101, and then let's go and see if that's now in game. We could go on an adventure and go and find this other voxel farm. It should be over here. And there should be a gap between them. And so now that we've got two, we can add a seed and see what happens if the seeds are different. Oh, and what I was going to say was, in terms of amplitude and frequency, it would be much more interesting to have the seed impact the amplitude and frequency, so that the seed number was actually involved in the algorithm for generating the terrain, and not simply finding a new location in the virtual Perlin terrain, and so giving the illusion of a new terrain kind of generated from that seed number. That will make sense if you look at a couple of videos ago that I made when I first made the seed number. There isn't a gap. Let's pause this. Camille Farm. If I zoom out. Oh, there we go. And I want to look down on the Y dimension. Okay, we've definitely got two voxel farms. Oh, there is a gap. There's definitely a gap, but I've missed it. I somehow jumped over it. Where am I? Me. Oh, I'm down there. I'm only in the middle of the terrain. I thought I was on the edge. I definitely went over the gap then. Did you spot the gap as I was walking? Was I talking and then missed it? I did get distracted actually. There was I think it was like this little section that reminded me of Superman's home in the ice with the crystals, and and I was looking at that. Oh, was that the gap? I can't find the gap. I've got to be over halfway now. I mean, I'm really sorry. This serves no purpose. Yeah, admit the gap is undetectable. Well, there you go. If you want to have a gap in the middle of your terrain, that seems to be fine. It won't upset anyone. Let's make a larger gap. Camille Farm 101. Ooh, we'll make you 110. That should be a significant gap in the terrain. Let's go and find that now. I can see it, surely. I can see it there. This is a very interesting part of the Perlin noise terrain. It's like a really straight ledge. I quite like it. Let's walk along this bridge. Which is kind of, it's interesting because it's generated from pseudo randomness, so it's genuinely like there are things to discover in the landscape in terms of its features. And here there's almost like a grid. That's really cool. Anyway, seed number is 0. Okay, that's kind of cool as well. Now we've got the sheer drop. Have I just fallen down? Yeah. There we go. So we've definitely got a gap now, so we can see our two voxel farms. Right, let's get going. We haven't done any coding yet, so we want to add a seed component to our code here. Right, so we want a public seed. It's going to be an integer. You could make it a float, that'd be fine, it'll work with the algorithm. And the default value we'll say is 0. Okay, so where does the seed go? I don't really need to talk too much about this because I covered it in a previous video, but it will play a role in where we're looking in terms of the two-dimensional Perlin noise. So I'm going to add it to just the X component. This Perlin noise function, by the way, it takes in an X and a Y, or thinking about the three-dimensional space, X and Z. And then that will return a number between 0 and 1. And then I need to scale that up by the amplitude, and that means kind of like the volume, or the in terms of like a sound wave, or just how big the waves are going to be, or hills are going to be for our terrain. I'm getting distracted by the fact that the script should not be looking that color. I don't know what's going on. It's because I've like broken it, but it's still working. Anyway, right, we've got a seed. So our Camille farm and our Voxel farm have now got a space for their seeds. So we can have radically different seeds. So we can have one, what a big change from 0. 1 for Voxel farm, and then let's have 9999999 for Camille. And then when we run, they will have, they will be starting from different positions in the Perlin terrain. Well, interestingly, we've still got like a bridge. Oh yeah, of course, because the first Voxel farm we changed from 0 to 1, so its landscape's going to be almost identical. Now, notice that if I go up on this high crest, if we had positioned Camille Voxel farm where it should be, these terrains would not line up, and so you get a complete mismatch. Although it'd be very hard to see because I've got these really long voxels, it will kind of disguise the fact that there was a seam here. And indeed, even when there was a single gap, I found it difficult to see it. So it's important to have the same seed, unless you want to create variety that will include a seam between your voxel farms. So what we've really got to have is like a third party. We've got to have another empty game object that will be kind of our seed manager. There we go. So we've got a seed manager in there, which at the moment we could just put it in the middle of the world. It doesn't matter where it is, doesn't matter what scale. We're not going to be able to see it. You could attach a model to it, but it would be purely aesthetic. It wouldn't do anything. But we need to write a script that will control what seed each of our farms are going to have. And if you were creating like an infinite terrain where you were kind of like moving these farms around as your player moved to give the illusion of an infinite terrain, which I'd love to do, I must work out how to do it in a good way and do that in the next video or something, then you'd want the seed to be consistent. I also now want to make sure that the seed impacts upon how the terrain looks, so it will change the frequency and the amplitude. So first, let's just make sure that our seeds are always the same. So we need a new script, make this in C#, and we'll call this the seed brain. There we go. Okay. And this is going to be quite simple. All we want to do is reproduce the feature of our seeding farm of having a seed number public. My colors are back again. It didn't like the fact, my project didn't like the fact that I deleted that script. Oh, that's lovely. I'm so pleased, it looks nice again. I hope this font size is okay for you, let me know if not. So in generate terrain, before this seed is used, we want to make sure that seed brain has told us what seed to use. So we won't need starter update in our seed brain. We just need a public int seed. There we go. And again, we'll have the default value set to 0. So have I attached this script to the seed manager? No. No. So I need to do that. Right. So seed brain attached there, and we can see the public variable 0. So we can change the seed in the inspector, which is nice. But this, of course, has nothing to do yet with our voxel farms, Voxel farm and Camille farm. Okay. So we really want to decide who's going to talk to who. Is the seed manager going to talk to each individual voxel farm, or is each individual voxel farm going to talk to, start the conversation with the seed manager? And this is, I heard it somewhere in some kind of video about programming. This is really the essence of object-oriented programming. So not really that you've got objects with each separate script on, although that's kind of essential in a way, but the fact that those different objects can communicate to one another and will control their own data. That's really the essence of object-oriented programming. So I think it makes sense for when each voxel farm wants to generate its terrain, it knows that it needs a seed. So it kind of makes sense for it to go and ask the seed manager for the seed that all the other voxel farms are using. So generate terrain, maybe we should write a function called getMySeed. There we go. And we better write that. It'd be nice. I haven't written enough functions with return values. So let's say it returns an integer. Because it returns something, it kind of reflects the name of the function a little better. So we'll say seed equals getMySeed, and so this function wants to return a seed that we get from the seed manager. So how do you talk to another object? So one way you can do that is by using the GameObject.find function, and then you can put in here the name of the game object you want to find. So I think I called it seed manager. I've got to be careful there because this string has to match this string, seed manager, exactly. So lowercase, uppercase, seed manager, all together, no spaces, that's exactly the same. So I need to obviously store whatever this function finds in the appropriate variable. So the appropriate variable will be a game object. So game object, and we'll call it seed manager equals that. I've just called it, I've used an underscore, so I know it's kind of separate in my mind from the actual seed manager object out here. So it's not the game object, it's just the variable we're storing that game object in. Okay, so we've now kind of got hold of another game object, and what we're really after is this script, the seed brain, and in particular, specifically, the seed number that script is holding. Here it is in the inspector. So there's a seed brain script, and it's got that seed on it. So we need to get hold of that. Now we can do that now that we've got hold of our seed manager. So we can say return. I'll just delete this white space. There's an error here. Oh, probably because we haven't returned anything yet. So return seed manager dot get component. So we're grabbing a component, and the component we want to grab is the seed brain. And if it's a script, it will come up in the mono developer list, which is nice. So seed brain brackets dot, and now we can go and get the seed. There we go. Brilliant. And all the colours have gone the correct colour. So that will now getMySeed, will return the seed that's on the seed manager. Now let's just see if this has worked. The seed is 0 on the seed manager, although no it isn't, it's 999. On Voxel Farm presently, the seed is 1, and on Camille it's 9999999. Right, so if we run both of those scripts that control generating the terrain, before they generate, they should go and get the seed from the same place. So they should be both set to 999, which I could just go and very easily check now by pausing the game and looking at their seed numbers. But I'd rather first just go and run to the edge, the gap, and just see by eye if it seems to line up. It already looks like that way. I've got this nice feature Please don't fall off. There we go. So the terrain is looking like it lines up exactly. There we go. So it looks like the seed numbers are going to line up. Okay, but let's just check that. It could just be illusion. It could just be an illusion. Right, so Voxel Farm, seed number 999, Camille Farm 999, and that's because they're both derived from the seed on our seed brain, which is 999. Okay, so good so far. So that's worked. So that's how you might coordinate your seed numbers. So the next thing we need to do is use the seed in a more interesting way. We could have let's have a randomizing function on the seed brain. Oh, by the way, if I made this variable private, or more to the point, didn't make it public, then if we try and run now, it should run into an error. Yes, all compiler errors have to be fixed before we can enter play mode. So, keep in mind, oh, that does appear there. Oh, that's interesting. I didn't know that was going to appear in the seed brain script. Because it's private, maybe because it's up here, it's not within a function. I didn't realise. I thought every time you made an integer public, that's what caused it to be seen in the inspector. Unless that hasn't changed back because there's a it might not have altered because there's a fault on the other, there's a bug on the other script. If I just comment that out, in fact comment all that out. Now will that disappear from the inspector? Yes, it does. Okay, I'm not going crazy. Right, meaning, yes, if this is private, it won't appear in the inspector, but just as you just saw, it means other scripts can't access it, which is a way you would control kind of the complexity of what's happening with your data and information, so that it's easier to debug later on. I.e., you know which individual script is affecting what data and stuff. So what I'm doing actually is quite bad. I'm allowing scripts to kind of, well, I'm not changing the seed number, so I'm okay. But if you allow different scripts to change the seed number, for instance, and there was a problem, a bug, it could involve any one of those different game objects, and so you'll be in trouble to try and debug it. Okay, right. So we want that, definitely we want that public, and I want to uncomment those and uncomment that. And so we want to make this seed number, once we've grabbed it, affect our frequency and amplitude. So I haven't really done this before. So the essential thing is the seed number is has certain characteristics. So it's kind of like mathematics, which I don't know anything about, but you can ask of that number certain questions like, are you odd? Are you a multiple of 94? Do you like poached eggs? Can you fit within a certain area if we doubled you up or something? I don't know. You can ask different kind of like mathematical questions about it, and depending on the different answers you get, you could then change the features of the terrain. And so in that way, the seed number has meaning in terms of what it will manifest for your voxel terrain. So I think that's quite an interesting thing to do. So let's have a go. This is my first time at this. So what we really want to do, let's affect the frequency and the amplitude, and we can play around with these quite freely because our voxel stalks are really elongated. So if we stretch the terrain out where there would ordinarily be massive gaps, now we can play around with it, and those gaps won't be too, well, there won't be any gaps unless we stretch it too extremely. But then again, we can stretch out our voxels. So let's say something like, oh, I don't want to have the, say the amplitude. That's what I want to work with first. No, let's work with the frequency. Let's just say the frequency equals sorry, I'm just imagining you. Well, let me just type. Right, make it up. Creative coding. Okay. The frequency equals the seed divided by 1, 2, 3. There we go. If frequency less than, can you have it a minus number? Well, let's just leave it. We should make a function really to tidy this code up. So let's say terrain features okay, so void or a method terrain features, and then here we go and mess around with the frequency. So we can mess around with these variables because they're all public. Frequencies up here, seeds up here, so we can use it in any function we like. Okay, let's let's see what happens there. So I can't remember what on earth. Oh, what have I done now? Oh, I haven't publicized this, or I haven't saved the script. Save. There we go. I think we've broken something. It's just gone black. Oh, now it's working. Oh my goodness. Right, invalid. We're getting invalid positions. Look at this. So that was a disaster. Let's just think about explicitly what I was doing. So what does the frequency equal? 10 by 10. In the inspector, what is it? It's 2010. So the frequency I was dividing by these massive numbers. That's after. Make sure I'm doing this after we've got my seed. Yes, you get the seed. So I'm just thinking there, you want to make sure that all of the voxel farms are getting the same seed before it works out its terrain features, so that they all get the same terrain features because they've got the same seed. So I'm dividing, what, 10 by by this number. Let's use a sine function. So let's times it. Let's go the other way. Times by 12. And we'll say the amplitude by 12. Or by 3. Let's not go crazy. Although these numbers need to be... I'm not thinking about... I need to plan this, don't I, beforehand to do like a tutorial on what would actually work. I'm just thinking on the fly. You would need to meaningfully think about the values that these equations would produce, output, because you want your if you don't want like a flat world or a ridiculously elongated world, then you've got to have kind of like maximum and minimum ranges on these things. And I just want to throw in a load of randomness, which is not going to work. So, frequency that, seed is that. What was I going to do? I've forgotten. Let's just run this and see what happens now. I remember what I was going to do. Oh, this is not looking good again. Okay, I apologise. This is a disaster. Because what's happening in the algorithm is we're dividing by the frequency, and we are I think we've got a massive seed, have we? I can't remember. Where's our seed? Seed manager. Oh no, it's 0. Oh, so we're using 0. Let's just put 12 in there. It still might be. Yeah, we're still doing something ridiculous. So what I was going to say is we could use the sine function or the cosine function, because we don't really want there to be massive mountains just because the seed number is massive. We want to use a property more like is it odd, is it even, or what moment in the sine wave, which way are my hands going, which moment in the sine wave have you got to, depending on the journey of the seed number up the number line. So let's use the sine function. I think I did something like this in the previous video. And we'll just say the amplitude equals the frequency times 10. The frequency. There we go. Okay, if this doesn't produce something that looks like something, oh no. Oh no, we're okay. Okay, brilliant. Wow, we've got a very boxy kind of world here. It no longer looks like Perlin terrain. Okay, so what's happening? It'll be very spiky, I guess, and a very low frequency. So let's try a very low amplitude. So let's, I don't know, go 999. Basically the same thing. Let's just try beefing up the amplitude. Did I save that? Let's have a look. What else did I want to do? Sorry, I'm just thinking. I'll call this quits in terms of using the. Okay, at least we've got difference here. Okay, can I delete these? Can I dig my way out? Right, at least we've got some difference. Let's pause this one and just move around in the editor. Cool, that looks kind of amazing. But we've yeah, we've got quite a unusual terrain there. Oops. There we go. So you can see, I can't claim to have meaningfully used the seed number to change the terrain, but at least it's involved. You can see how you might use the seed number now to change the features of your landscape rather than just where you're deriving the Perlin numbers from in a two-dimensional Perlin terrain. Okay, so the other thing I want to do is make those trees look like trees. So I want to do this algorithmically, which is different to how I've kind of used the blocks. So at the moment, the blocks are prefabs. They're just objects like this that are pre-made, and they are. If I just show you the simple voxel form, I've used them to populate this array, and so the seeding farm script is just referring to that block, that prefab, and just instantiating them into the world. Whereas, we better delete this soil block. It's just floating around. Whereas, for the trees, if you look at the my speed coding video, this is how we create the trees. What is that? It's about 13 lines long. And all that's doing is saying, okay, for each block that we place down, is there like a 0.1% chance of creating a tree? If so, we are creating a primitive. So GameObject.create primitive type cube, and we're just creating a cube on top of the part of the terrain that we're dealing with, and then I give it a random height out of 24, and then I transform the position of the I alter the position of the tree to being over the correct voxel, and then lift it up so that it's sitting exactly on the surface. So what we really want to do after we've done that is generate like a big block at the top to look like a square tree. So what we could do is just create another block on the top and just increase its scale. That's what we could do. Right. So let's do that. Right. So let's say now for the head of the tree, the crown of the tree. I don't know what it's called. So we'll say I'm going to copy all of this. In fact, I'm going to copy all of that. And we just need to change the names of a few variables and a few dimensions. Yeah. Okay, so we'll call that GameObject.tree head equals that. We want a cube. Can we just, I think we can just stretch out the kind of like the magnitude of the of its scale. So we can say scale. Yeah, scale. I need a vector 3 scale. Okay, new vector 3 4 in that dimension 4. I think this is kind of making sense in my head, so I'm kind of stretching it out by magnitude of 4 in each dimension, so we've got a big block. And then we want to have it at the same position plus that number. So that's the height of the tree. Okay. That was very hacky. I've got to make sure that I'm referring to the tree head here. Oh, I've missed one there. Oh no, I want that to be tree babe because I'm using the tree babe, like the stalk of the tree, the trunk of the tree, to orientate the position. Right. Hack together. That felt really dirty and horrible. Oh my goodness. Okay. Oh, now I've got this ridiculous seed number. Let's so you can see what on earth is going on. It looked like the tree head was floating way up high and didn't look very big at all. So my scale function didn't seem to work. What on earth is terrain features? So I'm not going to go and do terrain features anymore. Let's now run that again. So we can go and inspect a tree. Go and find a tree and see what's going on. Okay, so it's floating really high. Well, it might be big, you know. Okay, so I'm pleased that it might be quite large. It's just because it's quite far away. Although, or is it? No, it looks like it's lining up. So this doesn't seem to be working. Tree head. Oh, yep, no, tree head. Tree head. Transform local scale. I mean, to my mind, you would just scale it by a scalar. And presumably this won't work because it was asking me for a vector 3. Yeah. Well, can I just say local scale times equals 4f? So this should at least make large tree heads. Yes! They kind of look like really bad mushrooms. Right. So we've got a tree head almost there. So now we've just got to adjust it down. So y plus adjust plus that. Maybe it's that divided by 2. What was that? That was the height of the tree. Nope. Just make sure that there didn't seem to be a change there. I had to save the script. Oh, I'm adjusting the adjust value. So I don't need to adjust that. So actually, I do need to have that there, but I don't need to change adjust. Okay. I'm very sorry, I'm not really commenting as I'm making changes there. So I'm not really explaining myself very well. Okay, so it's close. It's close. Now I think what I think I'm doing is I'm pointing to the screen. You can't really see. I think I'm adjusting the height of the tree head by the whole, maybe by the whole length of the tree trunk, when I need to be doing half that amount. I think that's the gist of it, something like that. This is very dodgy because clearly I don't know. Right, divide by 2f. But if the tree heads do now sit on top of the tree trunks, then something in me knows what it's doing, but not my brain. Okay, right. So that's kind of worked. We've got ridiculously looking trees. So we can just ask the question, why do they look stupid? Look stupid, one, because of their colour. So we could change the material, which I'm not going to do in this video, but they're too high. Or rather, the head of the tree isn't matching kind of its height. This looks okay. So we want to relate the scale to the height of the tree. Okay. So at the moment we're just saying the head of the tree is going to be at the scale of 4, and up here, so that the tree point y component, so that's its scale in the y direction of the trunk, is being assigned here a random value, maximum of 24 meters high. So where are we? We want to say the scale is so if we was about, what was that, about 4 to 4, so it wants to be the height of the tree. So if it's 4, it wants to be 4. So divided by 1. That'd be really bad. Oh my god! If you know any mathematics, you must be thinking he's an idiot, and I am an idiot. We don't want to match it exactly. Divided by, I want that to be 4, but as it kind of gets bigger, then will the scale need to get bigger proportionally? Oh, I don't know. Let's just have a straight correspondence between the height of the tree and the scale. I love it. You see, being dumb has its advantages, right? You get awesome things like this. Now they look like good mushrooms, you know? There we go. So divided by 4. Now I'm starting to cook. Plus 4. Okay, so we've got a bit of division in there and a bit of addition, so they're going to have different proportionality kind of consequences, if that makes any sense. Yeah, so our short trees might look a bit big in terms of their heads, and the really tall trees might look a bit small or something. Okay, but that's more like it. That's more like it. The taller trees have larger heads, and the short trees look okay. Okay, yes, that's giving me the sense of a tree now. Oh, I've gone down the gap, but there we go. That might be the end of the video. There you go. So we've coordinated some seed numbers. I've done a bad job in many things. We've tried to meaningfully involve, or I've shown you the door to how to meaningfully involve the seed number in the terrain generation, and we fiddle around with the trees there to look a little bit better. And I've also shown you the door to how to solve this layer problem if you wanted to dig down. Okay, in the comments let me know what you want me to do next, or I might just stop this project now if not. Okay, thank you very much for watching. I hope something in there was helpful.